All right, we're back. We're going to be working on page 5, but I just need to start here because on the next page, we're going to write this stuff as a summation, and it's a little scary. But there's almost never a reason to really do it, but also don't be afraid of it. But whatever. The pattern, the thing you really, really need to remember is that our nth term is going to be the nth derivative evaluated at the center, and then it's x minus the center to the nth power over n factorial. So there are like n's everywhere, which is super convenient. It makes it a lot easier to remember, I think. When you forget something, you're going to forget to center it. No one ever really forgets to put the center into the derivatives. Like people get that right, but then when they write their polynomial, they forget x minus the center to the n. They just write x to the n. So it's as if they're almost trying to center it at 0 despite the derivatives not matching. Like, come on, people, that's just not how it works. So the summation looks like this. And it looks kind of scary, and I wouldn't worry about this too much because eventually we're going to make the upper bound of the summation be infinity, and then we're going to put n on the lower bound, and everything will look right again. So I wouldn't worry about it. Just focus in on this right here. So it's going to be the nth derivative evaluated at the center. So we're going to write the Taylor polynomials for these functions. So let's see like if we can do it at any sort of speed. So should I name it? I'm going to name it p of x, I guess. P of x. So we already have everything that we need. So it's going to be 2 minus 4 x minus 3 to the first over 1 factorial plus 5 x minus 3 squared over 2 factorial plus 8 x minus 3 to the third over 3 factorial, and then plus 12 x minus 3 to the fourth over 4 factorial. So like, what do you know about this function? Almost nothing. You know the exact value at 3. So you know the exact value at all of the derivatives, and that's it. You don't know what function you're dealing with. You don't know anything other than at 3. You can approximate things that are close to 3, but you can't find the exact value. The only things you definitively know based on the polynomial for the function are the exact values of the derivatives of the function at the center. That's it. You don't know anything else. And also, I'm not going to even simplify that. So here we're going to get p of x is 3 minus 2. It's going to be x plus 1 to the first over 1 factorial, but I'm not going to do that. 6 x plus 1 squared, 2 factorial plus 7 x plus 1 cubed over 3 factorial, minus 4 x plus 1 to the fourth over 4 factorial, and then finally plus 12 x plus 1 to the fifth over 5 factorial. I don't know. Like once you got it down, you got it down. I don't know if we need to do all these. How many are there? Oh, there's so many. All right, let's keep going. 10. I don't know if you can tell that I really want to stop, but you know, doing it for you guys. So hope your notes are looking good. So once you have the pattern, I believe you will never forget it, which is part of why we're doing so many of these. But also, I definitely acknowledge this is annoying. And actually, I'd be surprised if anybody's watching the video because it's almost like it's not hard enough to like need to watch someone do it. This one's just going to look ugly because there's nothing you can really do. Polynomial, so you're just going to have like root 2s. It's strange. X plus 2 first plus root 2 x plus 2 squared over 2 factorial minus 4 x plus 2 to the third over 3 factorial. I wonder what function this came from. Like, so sometimes, usually what I do is I just pick a function and have the calculator like generate the derivatives, and then I just like fill them in a table. Although also sometimes I just randomly make stuff up because like it doesn't really matter. We're just trying to like learn a technique. So, you know, you can do whatever you want. I don't know what would do this, where it's root 2 every other derivative. I really can't think of anything. And then it's like power, no, it's not powers of 2. Oh, it's just always -4 every other. Root 2 and or -4. That's weird. Strange pattern there. This one's going to be really weird because it's centered at pi. So like usually what you fill in, what you substitute would be like pi plus 0.01, something like that. They used to do that a lot on like the way back AP exam. like in the 60s, you'll see problems that look like that. I'll be like, and then evaluate your polynomial at pi minus 0.2. You're like, that's a weird value. Until you realize it's centered at x minus pi, so pi minus 0.2 minus pi is just minus 0.2. So it's actually like easier, but until you like notice that, it's kind of weird. A minus, a plus, oh no, I already did this one. I was gonna say there's a lot of 2/7 here. 9/5, man. 9/5. I don't know what I'm even saying. Cubed, 3 factorial. 4, x minus pi to the 4th over 4 factorial. A lot of 4s. My brain starts getting really, oh yes. My brain starts getting really confused when I have to keep saying the same number over and over. And yours probably does too, and you just don't have to do it as often. Try it though. It's like you can create your own tongue twisters. So try to be really careful here not to lose, not to forget the center. It's embarrassing to do that. What is happening? Cubed over 3. This just looks like lazy problem writing. All right, I basically just like did the same thing a bunch of times. Plus 3, x plus, okay. X plus, sometimes when I like scroll really fast, I just gotta wait. You just gotta sit there and wait it out. These are all Taylor polynomials. We don't know what function they are Taylor polynomials for. It doesn't matter. I mean, these are the Taylor polynomials. So this is a 5th degree polynomial because we go up to the 5th derivative, 4th degree because we matched up to the 4th. So when you talk about the degree of a Taylor polynomial, you're referring to like you take your polynomial and you show it to like an algebra 2 student. You say, what degree polynomial is this? And they'll be like, that's a 6th degree polynomial. And that's all you're talking about. So later it will get a little confused when like to get to the 6th degree polynomial, you'll have to use only like 3 derivatives or something like that, because maybe you're like squaring something. So like you'll have x cubed but squared, and so it's x to the 6th. That's a 6th degree polynomial if the highest power of x is to the 6th. So this page, pretty straightforward, I think. But we got like a couple little nuances coming up. But anyway, if you have this memorized, you are off to a great start, because any of these problems, something that you definitely need to be able to do. So I'll see you in the next video for some more stuff, and I hope you're still there. So see you then.